Where were you on July 20th, 1969? It was a day that would be etched into the annals of history. A day when humanity reached beyond the confines of our blue planet and set foot on another celestial body. Millions around the world huddled around their television sets, eyes glued to the grainy black and white images. Families gathered, friends united, and strangers stood side by side in awe, sharing a collective moment of wonder and disbelief. Neil Armstrong, an American astronaut, descended a ladder. Each step he took was a step into the unknown, a step that symbolized the culmination of years of relentless effort, innovation, and dreams. He planted his foot on the dusty lunar surface and declared, "That's one small step for man, one giant leap for mankind." These words echoed through time, becoming a testament to human ingenuity and courage. Or so the story goes. For every monumental achievement, there are whispers of doubt and skepticism. The Apollo 11 moon landing remains one of humanity's most celebrated achievements. It marked a pinnacle in space exploration, a moment when the impossible became possible. But what if it was all a carefully constructed illusion, a Cold War fabrication meant to bolster American prestige? The space race was not just about exploration, it was a battle for supremacy, a demonstration of technological and ideological dominance. While the official narrative is widely accepted, a persistent undercurrent of skepticism remains. Some question the authenticity of the event, suggesting that what we saw was a masterful piece of propaganda. Conspiracy theories abound, questioning the authenticity of the moon landing. They propose that the entire event was staged, filmed on a secret set somewhere on Earth. They point to inconsistencies in the photographic and video evidence. Shadows that don't align, flags that appear to flutter in a vacuum, and reflections that seem out of place. They claim the technological limitations of the 1960s made such a feat impossible. The computers of the time were less powerful than today's smartphones, and the challenges of space travel were immense. Were we truly witnesses to history, or were we being sold a magnificent lie? The question lingers, casting a shadow over one of humanity's proudest moments. Let's examine the evidence, both for and against, and take a closer look at this pivotal moment in human history. By delving into the details, we can better understand the complexities and controversies that surround the Apollo 11 mission. Experts, historians, and scientists have weighed in on the debate, providing insights and analyses that either support or refute the claims of a hoax. Their perspectives offer a deeper understanding of the event and its significance. NASA's archives hold a treasure trove of original documents and footage from the Apollo 11 mission. These records provide a detailed account of the mission's planning, execution, and aftermath. Since 1969, technological advancements have transformed space exploration. Modern missions to the moon and beyond build on the legacy of Apollo 11, pushing the boundaries of what is possible. Public opinion remains divided. Interviews with people who witnessed the event reveal a mix of awe, pride, and skepticism. For some, the moon landing is an undeniable fact. For others, it remains a tantalizing mystery. As we look to the future of space exploration, the questions raised by the Apollo 11 mission continue to resonate. Human missions to Mars and beyond will face similar scrutiny and skepticism. Reflecting on the legacy of Apollo 11, we are reminded of the power of human achievement. Whether you believe in the moon landing or question its authenticity, the story of Apollo 11 is a testament to our enduring quest for knowledge and exploration. The moon, a silent witness to our dreams and doubts, continues to inspire us. As we gaze up at its pale surface, we are reminded of the boundless possibilities that lie beyond our world. One small step, one giant leap of faith. One of the most frequently cited pieces of evidence presented by conspiracy theorists concerns the shadows cast in the lunar photographs. These shadows, they argue, are not parallel as they should be if illuminated by a single light source, the sun. This, they claim, suggests multiple artificial light sources were employed on a stage set. However, this argument reveals a fundamental misunderstanding of perspective and topography. Just as railroad tracks appear to converge in the distance, parallel lines on an uneven surface can cast shadows that appear non-parallel. The lunar surface, far from being flat, is riddled with craters and hills. These irregularities can easily distort the appearance of shadows, creating the illusion of multiple light sources where there is only one. Furthermore, the camera lens itself can introduce distortions. further complicating the picture. Another anomaly frequently pointed out by skeptics is the American flag planted on the moon. This iconic image has been the subject of much debate and speculation over the years. In photographs and video footage, the flag appears to be waving in the breeze. This has led many to question the authenticity of the moon landing, suggesting that such movement is impossible in the vacuum of space. Impossible, they cry, in the vacuum of space where there is no air to generate wind. The vacuum of space is a place devoid of atmosphere, where traditional concepts of wind and air currents simply do not apply. This observation, while initially perplexing, has a simple and perfectly logical explanation. It's a fascinating example of how our earthbound experiences can sometimes mislead us when interpreting events in the unique environment of space. The flag was designed with a telescopic pole to ensure it stood out proudly for the cameras. This pole was crucial because without an atmosphere, the flag would otherwise hang limply, failing to create the desired visual impact. The wrinkles in the flag, mistaken for the effects of a breeze, were actually caused by the way it was folded and stored during the journey. The flag had been tightly packed for the trip to the moon, and these creases remained when it was unfurled. These wrinkles were simply held in place by the fabric's own stiffness and the lack of any strong gravitational force on the moon. The moon's gravity is only about 1/6 that of Earth's, which means objects behave differently than they do here. The appearance of movement is likely due to the astronauts rotating the pole to secure it in the lunar soil, causing the flag to oscillate briefly. This motion, combined with the flag's inherent stiffness, created the illusion of it waving. When the astronauts planted the flag, they had to twist and turn the pole to drive it into the lunar soil. This action imparted energy to the flag, causing it to move. In the absence of air resistance, the flag continued to oscillate for a longer period than it would on Earth. Additionally, the flag's fabric was specially designed to withstand the harsh conditions of space. Its material was chosen to be durable and to maintain its shape, even in the extreme temperatures and radiation of the lunar environment. Engineers took great care in designing the flag to ensure it would be a lasting symbol of human achievement. They anticipated the challenges of displaying a flag in a vacuum and created a solution that would allow it to be seen clearly in photographs and video. The waving flag on the moon has become an enduring image, symbolizing not just the success of the Apollo missions, but also the ingenuity and determination of the people who made it possible. It's a testament to human curiosity and our desire to explore the unknown. As we continue to venture into space, we carry with us the lessons learned from these early missions. Understanding the unique conditions of space helps us to better prepare for future explorations and to solve the mysteries that await us beyond our home planet. The story of the waving flag on the moon is a reminder that our journey into space is filled with challenges and surprises. It encourages us to look beyond the surface and to seek out the deeper truths that lie beneath. So the next time you see that iconic image of the flag on the moon, remember the science and engineering that made it possible. It's not just a flag, it's a symbol of human achievement and our unending quest for knowledge. Starry, starry night, or lack thereof. The absence of stars in the Apollo mission photographs has fueled countless conspiracy theories. Skeptics argue that if the Apollo landings were real, the photographs taken on the moon should be filled with stars, given the lack of atmospheric distortion that we experience on Earth. This argument has been a cornerstone for those who believe the moon landings were staged. If the landings were genuine, the argument goes, the photographs should be teeming with stars due to the lack of atmospheric distortion. The clarity of space, devoid of the Earth's atmosphere, should theoretically make stars more visible and prominent in any photograph taken from the lunar surface. This assertion, however, betrays a fundamental misunderstanding of photography. The principles of exposure, aperture, and shutter speed play a crucial role in what is captured in a photograph. Simply put, the conditions required to photograph the lunar surface are vastly different from those needed to capture the faint light of distant stars. Capturing both brightly lit objects on the lunar surface and faint stars in the background simultaneously presents a significant photographic challenge. The moon's surface, illuminated by the sun, is extremely bright. To capture this brightness without overexposing the image, astronauts had to use specific camera settings. The lunar surface, bathed in sunlight, required a fast shutter speed and small aperture to prevent overexposure. These settings are essential to ensure that the details of the lunar landscape and the astronauts themselves are captured clearly and sharply. These settings, necessary to capture clear images of the astronauts and lunar landscape, would have made it impossible to capture the relatively dim light from distant stars. The stars, while present, are simply too faint to be recorded with the same exposure settings used for the brightly lit lunar surface. The stars are there, just not visible in the photographs due to the limitations of the camera technology and the specific photographic requirements of the mission. The cameras used during the Apollo missions were designed to capture the details of the lunar surface and the activities of the astronauts, not the distant stars. Astronauts had to adjust their camera settings meticulously to deal with the harsh lighting conditions on the moon. The bright sunlight reflecting off the lunar surface required them to use settings that would naturally exclude the faint light of stars. On Earth, night sky photography often involves long exposure times and wide apertures to capture the faint light of stars. In contrast, the conditions on the moon necessitated the opposite approach. The need for fast shutter speeds and small apertures to avoid overexposure meant that stars would not appear in the photographs. It's also important to consider the technological limitations of the era. The cameras used during the Apollo missions were state-of-the-art for their time, but they were not designed with the capability to capture both the bright lunar surface and the faint stars simultaneously. Modern cameras with advanced sensors and dynamic range might handle this better, but such technology was not available during the Apollo missions. The absence of stars in the Apollo mission photographs is not evidence of a hoax, but rather a testament to the challenges and limitations of space photography. Understanding these nuances helps reaffirm the authenticity of the Apollo mission photographs and the incredible achievements of the astronauts who captured them. The Van Allen Belts, a radioactive roadblock? The Van Allen Belts, two donut-shaped regions of intense radiation surrounding Earth, are often cited as an insurmountable obstacle to human spaceflight. Conspiracy theorists claim the radiation levels within these belts would have been lethal to the Apollo astronauts, making a moon landing impossible. While it is true that the Van Allen belts pose a significant radiation hazard, their danger is often overstated. The Apollo missions were designed to minimize exposure to these belts. The spacecraft followed a trajectory that passed through the thinnest part of the belts. Moreover, the astronauts were protected by the spacecraft's shielding and their spacesuits. While the astronauts did receive a higher dose of radiation than they would have on Earth, it was well within acceptable limits and not enough to cause immediate health problems.